In the beginning, all that Stefan Schlaminger wanted to do was to write down an equation that would help him obtain a more precise value for g, the gravitational constant that determines the strength of the attraction between massive objects. To gauge that attraction, Schlaminger, a physicist at the National Institute of Standards and Technology, NIST, and his colleagues, studied the motion of a so-called torsional pendulum. In this case, a set of masses suspended by a thin wire that periodically twists and untwists instead of periodic. The equation that Schlaminger derived provides guidance about how to minimize or quickly dampen the amount by which the wire twists back and forth. If the amount is small, it's easier to locate and measure the position of the wire, which translates into a more accurate measure of g. Schlaminger was eager to immediately publish the result. But then he got to thinking. The finding would interest only a small number of people, those who measure g using the torsional pendulum method. Could the equation be applied to other devices? Turns out he didn't have to crane very far to find a connection. Moreover, a crane's cable and the load can be modeled as a vertical pendulum that moves to and fro in a manner similar to the way that a torsional pendulum twists and untwists. The time that it takes for the pendulum to complete one cycle of this motion is called the period. Applying the equation he had derived for the torsional pendulum, Schlaminger found he could predict the strength and timing of the changes in velocity crane operators need to apply to the trolley, the wheeled mechanism that moves loads horizontally along a rail. If a crane operator transports a load that's at rest and moves at a relatively short distance, the equation suggests this prescription for stopping the load at the right spot. The operator should initially apply a velocity opposing the motion of the crane's trolley and then apply exactly the same V. If the operator has to pick up a load initially at rest and move at a relatively large distance, tens of meters, the equation provides different guidance to account for the crane's larger swinging motion in this scenario. The operator should initially apply a force that accelerates the crane troll. Things get more complicated if the load has some initial swinging motion of its own, independent of the crane. In such cases, the two times at which the operator applies a force to bring the load under control are no longer exactly half a period or one period apart, but the equation still provides the appropriate times for action. This is really a rich application that is worth sharing with the world, he added. Satisfied that the work would reach a wider audience, he and his collaborators, including Newell, Leon Chow and Vincent Lee of NIST, along with Clive Speake of the University of Birmingham in England, were finally ready to publish. American Journal of Physics, 2022. 93, 169 doi. 10. 1119 tenths. 0006965 National Institute of Standards and Technology, NIST. Researchers link cutting-edge gravity research to safer operation of construction cranes. Science Daily. https://ift. tt. Ohm 6 CYA8. Accessed February 18, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.